In the name of Allah, the most gracious, the most merciful, my name is Mahasabir and I am a student of BS Biotechnology from University of Management and Technology. Today, the topic of my presentation is the device which we always have in our hands. Yes, it's about mobile phone. So, the topic is chemistry of mobile phones. Here is the contents table. We will discuss about what is mobile phone, its history, evolution, softwares, hardware, composition, manufacturing, chemical elements of mobile phone, metals, electronics, conductors, batteries, process of operating batteries, screen chemistry, fingerprint sensors, use of plastics, silicone, radiations, advantages and disadvantages of mobile phone, impacts on environment, steps to make them usable in circular economy. Let's start. What is a mobile phone? A mobile phone is a portable electronic device. It is mainly used for communication, and communication can be in the form of video calls, voice calls, text messages, sending emails. And a major use of mobile phone is for photography. And in today's era, mobile phone is using for internet connectivity, and you all know that internet have made the world a global village. History of mobile phones. Mobile phones have evolved significantly. The first ever mobile phone was made in 1970s. Its name was Motorola Dynatec 8000X. It was large, heavy and primarily intended for voice calls. As you can see in this picture, its size is large, so it's not portable. Evolution in mobile phones. In 1990s, the major evolution have been made in mobile phones. You can see in this picture the size of mobile phones have been decreasing and their functions increasing significantly. The early 2000s saw the rise of smartphones with basic features like email and internet browsing. Revolution in mobile phones. In 1992, IBM company first announced a touchscreen phone. It was Simon Personal Communicator. The Simon Personal Communicator was the first touchscreen phone. It had the ability to send and receive both emails and faxes. After it, in 2007, Apple's iPhone was launched. It was a great revolution for mobile phone industries. Google's Android operating system also played a crucial role in the proliferation of smartphones. Over the time, mobile phones have been evolving and now we have smartphones. Over the years, smartphones become more powerful, incorporating advanced features like high quality cameras and extra. Mobile phone companies are developing ongoing 5G technology, foldable phones, multiple cameras, and wearable devices shaping the future of mobile communication. Smartphones are made up of 40 to 30 different chemical elements. Mobile phones are a combination of different software and hardware devices. What are hardwares? Hardware devices are the parts of a mobile phone which we can physically touch. Actually, hardware is equipment or machinery of mobile phone that is hidden inside its casing, so we can't see hardware devices of mobile phones. Which are hardware devices of mobile phones? The hardware components of mobile devices are central processing unit, which is also known as its brain, batteries, random access memory, which is RAM, ROM, that is read only memory, removable storage such as SD cards, input components such as mouthpiece or keyboard, and output components such as earpiece or screen. Hardware components of mobile phones are made up of different metal elements, conductors, and plastics. What is a software? Software is a computer program which tells the computer what to do. There are several mobile operating softwares nowadays. The two of them are mostly used. Number one is Apple's iPhone and number two is Google's Android. There are many basic application in softwares in mobile phones such as WhatsApp, Instagram, Facebook, Twitter, LinkedIn, and many games such as Candy Crush. And a popular game of today is PUBG and Free Fire. We can also play these games on mobile phones. Here is a difference between Android and Apple iPhones templates. How software is made. A computer programmer writes the instructions using a programming languages defining how the software should operate on structured data. There are many software languages such as C, C++, Java, Python, JavaScript. The program may then be interrupted or compiled into machine code. Sometimes two or more languages are used for making one particular software. Here are some components of mobile phones. There are two main sections of mobile phones. Number one is power section for its charging, and number two is network section for its functionality. Mobile phones are a combination of various technologies and components including communication technology. Mobile phones use radio frequency signals to connect to cellular networks, enabling voice calls, text messages, and data transmission. Central processing unit. Like a computer, mobile phone also have a CPU that processes instructions, manages applications, and controls the device function as it manages instructions. That's why it is also known as brain of any device. Memory. Mobile phones have both RAM, which is random access memory for temporary storage, and ROM for internal storage of apps, photos, and data. Display. The screen display information and allows user interaction. So screen is a very crucial part of any mobile phone because it is the main part between the interaction of user and mobile phone. Modern phones use LCD for liquid crystal display and LED light emitting diode technology for high quality displays. Battery. Mobile phones are powered by rechargeable batteries, typically lithium ion batteries, to provide the necessary energy for operation. Operating system. Phones run on operating systems such as Android, iOS, or others, which manage hardware and provide a platform for application. Sensors. Phones incorporate various sensors like accelerometers, gyroscopes, proximity sensors, and ambient light sensors for features like screen rotation, gesture control, and automatic brightness adjustment. And also, there are some fingerprint sensors in mobile phones. Connectivity. Mobile phones have various connectivity options, including Wi Fi for internet connectivity, Bluetooth for nearby share, GPS is global positioning system for location, and NFC enabling communications with other devices and services to communicate. Camera. Most smartphones include front and rear facing cameras for capturing photos and taking selfies, pictures, and videos. Nowadays, mobile phones have more than one camera for high quality pictures and more pixels. Microphones and speakers. These components enable voice communication and multimedia playback. Charging port. Mobile phones use USB C type or Lightning ports for charging and data transfer. Casing. The outer shell or casing is usually made of materials like plastic and metal such as aluminium or stainless steel or glass. SIM card slot. Mobile phones use SIM cards to connect to a mobile network and identify the user. This combination of hardware and software components makes mobile phones versatile devices that serve various communication, entertainment, and productivity purposes. You can see in this picture there's a top microphone in top center, and at bottom it's a bottom microphone. Manufacturing of mobile phone. The manufacturing of mobile phone involves following key steps. Number one is designing and planning of its whole structure. Number two is manufacturing of components. Various components such as the central processing unit, memory, display, camera modules, and sensors are manufactured separately by different suppliers. After their manufacturing, they are assembled together, and these components, after their assemblation, a software installed in the mobile phone. This includes the operating system, firmware, and any pre-installed applications. Quality control. Each phone undergoes rigorous testing to ensure that all components are functioning properly. Packaging. After passing quality control, the phones are packaged along with accessories such as chargers, cables, and user manuals. Distribution. The packaged phones are then distributed to retailers or directly to consumers through various channels. Sales and support. The phones are sold through retail outlets, online platforms, or directly from manufacturers. Ongoing Ongoing customer support is provided for troubleshooting and assistance. Composition of a mobile phone. Mobile phones can contain over 40 different chemical elements, including metals such as copper and tin, special metals including antimony and indium, and some precious metals such as gold and palladium, which are required for the device to function properly. On average, metals account for 23% of the mobile phone's weight, while plastics account for 50% of the weight. In this picture, showing a battery of mobile phone used chemical elements such as lithium and cobalt. For casing, metal, glass or plastic is used. For screen, glass, plastic and liquid crystalline mercury is used, and for electronics of mobile phones, silicone and different metals are used. Chemical elements of mobile phones. Copper is used for electron Copper is used in mobile phone for its wiring. In screen, silicone is used, and for casing, carbon is used because carbon is used in making plastic, and plastic is used for casing of mobile phone. Metals are what make smartphones so smart. An average smartphone may contain up to 62 different metals, which includes group of metals as conductors. Rare earth elements also play a vital role, and many other like cobalt, titanium, lithium, silicon, etc. Properties. Properties of metals are malleable and ductile, which means they can be converted into wires and sheets. Metals are good conductors of heat and electricity. Metals are lustrous and can be polished. Metals are solid at room temperature and they are tough and strong. Metals in the periodic table. Metals are found in periodic table on the left side. Group number 1 and 2 of the periodic table is known as alkaline earth metals, and from group number 3 to 12 they are transition metals. Uses of metals in mobile phones. Metals play crucial roles in mobile phones, such as aluminium and copper are common in the casing and wiring. Gold and silver are used in electronic components for conductivity and corrosion resistance. Rare earth elements contribute to screen colors and magnets in speakers. Additionally, metals like lithium and cobalt are vital in rechargeable batteries. One iPhone requires 46 elements, and it is a combination of all of these elements. Reasons why metals are used in mobile phones. Metals are used in mobile phones for various reasons. They produce structural support, help heat dissipation, and offer conductivity for electrical components. Common metals used in mobile phones are aluminium and tin for casing, copper for wiring, and gold for connectors due to its excellent conductivity and corrosion resistance. Now we will discuss different type of metals which use in mobile phones. Number 1, copper. Copper is a chemical element with symbol Cu, atomic number 29, and its mass number is 63. It is a soft, malleable and ductile metal with very high thermal and electrical conductivity. A freshly exposed surface of pure copper has a pinkish orange color. You can see in this picture copper metal. Electronic configuration of copper is given. It is present in D block, period number 4 in group 11. Its density at room temperature is 8.96 grams per cubic centimeter, and its density when liquid at melting point reduces to 8.02 grams per cubic centimeter. Uses. Copper is used in mobile phones for various purposes, including wiring and electrical components. It is an excellent conductor of heat and electricity, while making it crucial for its efficient functioning of electronic circuits within the phone. Copper is also used in the production of connectors, antennas, and other components that require a reliable and conductive material. Additionally, copper's durability and ability to dissipate heat make it valuable in mobile phones manufacturing. Copper element of the smartphone. There are about 0.5 grams of copper in your phone. That's make more than 12% of your phone's total weight. Recently, copper has been used in computer chips, resulting in much faster operating speeds and greater circuit integration. Up to 200 million transistors can be packed onto a single chip. The use of copper conductors in the chip in the last link is now unbroken carbon copper chain comprising the electronic data path between user and smartphone. Why copper is used in mobile phones? Copper is used in mobile phones for several reasons. Number one is it's highly conductive, so its great conductivity make it an excellent conductor of electricity to facilitate efficient transmission of signals within the phone. Number two, it's electromagnetic shielding. Copper is effective in blocking electromagnetic interference and radio frequency interference. This is crucial for ensuring the proper functioning of sensitive electronic components in the phone. Antimicrobial properties. Copper has natural antimicrobial properties which can help reduce the growth of bacteria, and some phones incorporate copper components for hygiene considerations. Recyclability. Copper is highly recyclable, making it an environmental friendly choice. So, the use of copper in mobile phones aligns with sustainability of efforts in electronic manufacturing and for managing e-waste. Aluminium is a chemical element with symbol Al, atomic number 13, and its mass number is 26.98. Aluminium is a silvery white lightweight metal. You can see its texture in this picture. Aluminium has a density lower than other common metals because it is lightweight. It is present in P block, period number 3 and group 13. Electronic configuration of aluminium is given. Its melting point is 933.47 kelvins. Its density at room temperature is 2.70 grams per cubic centimeter. Its density when liquid at melting point is 2.37 grams per cubic centimeter. Uses: aluminium is commonly used in mobile phones for their casings. Its lightweight yet durable nature provides a sturdy outer shell that protects the internal components. Aluminium offers good heat dissipation, helping to prevent overheating of the device. Its corrosion resistance ensures longevity of the device, and the metal's aesthetic appeal contribute to the sleek design of modern mobile devices. One iPhone contains over 31 grams of aluminium. Global uses of aluminium, such as in transport, 41%, 20% in packaging, 14% in construction, 7% in consumer durables, 7% in machinery, 8% in electronics, shows that global is aluminium is globally a very useful element. And why does it use in mobile phones? Aluminium is used in mobile phones for several reasons. Number one is due to its lightweight nature. Aluminium is a lightweight metal contributing to the overall lightness of mobile phones. It is crucial for making mobile phones portable and easy to carry. Durability: aluminium is also known for its strength and durable nature. Using aluminium is the construction of mobile phones enhances their structure integrity, making them more resistant to everyday wear and tear. Corrosion resistance: aluminium has natural corrosion resistance, protecting the phone's components from environmental factors like moisture and humidity. This helps extend the lifespan of mobile phones. Heat dissipation: aluminium is an excellent conductor of heat. It helps dissipate heat generated during the operation of the phone, preventing overheating and ensuring optimal performance. Aesthetics: aluminium's sleek and modern appearance contribute to the aesthetic appeal of mobile phones. It allows for stylish design while maintaining a premium look and feel. Gold. Gold is a very rare, expensive, and precious metal. So, is it used in your mobile phones? Yes, you heard it right. Gold is used in our mobile phones. There is a real gold in your mobile phones. So, let's see what is gold and its properties. Gold is a chemical element with symbol Au and atomic number 79. It's a bright, slight orange yellow metal. It is dense, soft, malleable, and ductile in the pure form. Chemically, gold is a transition metal. It is a D block element present in group number 11 and 6 period. Its electronic configuration is given. It is one of the least reactive chemical element. This is the reason that it's so rare and expensive. It is solid at room temperature. Its melting point is 1337.33 kelvins. Its boiling point is 3243 kelvins. Its density at room temperature is 19.3 grams per cubic centimeter. Its density when liquid at is 17.31 grams per cubic centimeter. Its natural occurrence is primordial. Its crystal structure is face-centered cubic. Uses of gold. The use of gold in making jewelry dates back to around 6,000 years ago. We all know that gold is used in jewelry. Gold has been used as a symbol of wealth and used for financial transactions in past. Gold is an effective medicine for controlling some type of arthritis and related diseases, so it have biological uses too. Uses of gold in mobile phones. There's actual gold in your mobile phones used because of its aluminium excellent conductivity and resistance to corrosion. However, the amount of gold in mobile phones is smaller than one might expect. On average, the amount of gold a mobile phone contains is 0.034 grams. Use of gold in mobile SIM cards. Gold is used in manufacturing of SIM cards due to it being a very excellent conductor of electricity. Other than this, there is a very durable. However, each SIM card contain very little amount of gold, and you need thousands of SIM cards to extract a few grams of. As gold is a rare element, so why does it used in our mobile phones? Because gold in mobile phones and SIM cards use because of its excellent conductivity and corrosion resistance. Gold's conductivity ensures efficient transmission of signals. Its resistance to corrosion helps maintain the integrity of the connections over time, contributing to the reliability and longevity of these electronic devices. Here you can see how gold is used in our mobile phones and SIM cards. Silicon. Silicon is a chemical element with symbol Si and atomic number 14. Its mass number is 28. It's a hard brittle. It is a hard brittle crystalline solid with a bluish gray metallic cluster. It's a tetravalent metalloid and semiconductor. It is a p-block element present in group 14 and period 3. Its electronic configuration is given. It is relatively unreactive. Its appearance is crystalline, reflective, and bluish tinted surfaces. Its melting point is 1687 kelvins. Its boiling point is 3538 kelvins. Its density at room temperature is 2.329 grams per cubic centimeter. Its density when liquid at its melting point is 2.57 grams per cubic centimeter. Its crystal structure is face-centered diamond cubic, and it is diamagnetic in nature. Uses of silicon. Silicon is of the most useful element of mankind. Most of it used to make alloys including aluminium silicon alloys and ferrosilicon alloys. Uses of silicon. Silicon is one of the most useful element to mankind. Most is used to make alloys such as aluminium silicon alloy and ferrosilicon alloys. They are used to make dynamo and transformer plates, engine blocks, cylinder heads, and machine tools to deoxidize steel. It is a major constituent in ceramics and bricks. Silicon is used in the production of fire bricks. It is a vital component of Portland cement. It is an essential ingredient for strengthening connective tissues, bones, and joints, as well as taking care of nails, hairs, and skins. The human body contains 7 grams of silicon, which is present in various tissues and body fluids. Silicon nitride. Silicon nitride is a highly thermodynamically stable compound of silicon. It is extremely high. It has extremely high mechanical strength. It is used in the applications involving high temperatures and strong shocks. Some more uses of silicon. Silicon is a key component of certain materials that play a role in these fields. Silica, which is composed of silicon and oxygen, is a fundamental component of many ceramics. Silica is often derived from sand and quartz, and it is a major ingredient in the production of various types of ceramic materials. It provides strength and stability to the finished products in pottery and ceramics. The biggest application of silicon nitride is found in the automobile industry, particularly the various wear and tear combustion parts in reciprocating engines where stresses at high temperature are prevalent. Uses in mobile phones. Silicon is a crucial component in mobile phones primarily because it is the main material used in semiconductors manufacturing and involved in manufacturing of following components. Uses in mobile phones. Silicon is a crucial component in mobile phones primarily because it is the main material used in semiconductors manufacturing and involved in manufacturing of following components. Microprocessors. Silicon microprocessors serve as the brains of mobile devices, executing instructions and managing various tasks. The integration of millions of or even billions of transistors on a single silicon chip enable the powerful computing capabilities of modern smartphones. Memory. Silicon is also used in the production of memory chips such as RAM and flash memory. These components are essential for storing and quickly accessing data in mobile phones. Power management. Silicon is based Silicon based components are used in high power management circuits to regulate and optimize the energy consumption of mobile devices. This helps in extending battery life and improving overall energy efficiency of mobile phones. Semiconductors. Let's see what are semiconductors. Semiconductors are materials whose properties lie between conductors and insulators and they behave as conductors. Semiconductors typically made from silicon and are fundamental to the functioning of electronic devices. Silicon's unique property as a semiconductor allow it to control the flow of electrical current. This is the bias for creating transistors, which are the building blocks of electronic devices. Transistors enable the processing and amplification of electronic signals in mobile phones. Here are some transistor devices or semiconductor devices. Carbon. Carbon is derived from a Latin word carbo, which means coal. It is a chemical element. It has symbol C, atomic number 6, and its mass number is 12. It is non-metallic and tetravalent, meaning that it its atoms are able to form four covalent bonds due to its valence shell exhibiting four electrons. It belongs to group 14 of the periodic table and it's present in D block. Carbon makes about 0.025% of Earth's crust. There are three main isotopes of carbon which are naturally occurring: C12, C13, and C14. C12 and C13 are being stable, while C14 is a radioactive isotope which decay with a half-life of about 5,730 years. Carbon is one of the few elements since antiquity. Is the fifth most abundant element in the Earth's crust. Here you can see the atomic number of carbon, which is 16, mass number 12, appearance. There are two main forms of carbon in which it exists. Number one is diamond and number two is graphite. Appearance of diamond is like a clear face centered cubic crystal structure you can see in these pictures, and graphite is a black colored metallic looking hexagonal structure. Uses: the computer screen on which you are reading, the clothes that you are wearing, the food that you eat, and even the cars in which you ride all have one thing in common. What is that thing? That thing is that thing common is carbon. They all are comprised of some elements of carbon. Actually, all organic things are made up of carbon. It makes for 18% of human body in the form of sugars, glucose, proteins. Carbon in its diamond form is used in jewelry. Amorphous carbon is used for making inks and paints. Graphite is used as the lead in your pencils. One of the most important uses is carbon dating. Here is the example of some compounds of carbon. Our DNA also contains carbon. Uses of carbon in mobile phones. Carbon is used in the manufacturing of plastics, which are commonly found in casings of mobile phones and in the form of anode in lithium ion batteries. In lithium ion batteries, graphite, a form of carbon, is used in the. Why carbon is used in mobile phone batteries? Carbon prolongs the battery's overall life and stop the loss of active materials during cycling. Carbon black also improves the bond between the current collectors and active materials, which lowers internal resistance and raises overall efficiency of the mobile phone. The carbon anode helps maintain the stability and performance of the battery, contributing to its overall energy storage capabilities. However, it's crucial to note that while carbon is involved in the battery's composition, it is just one component among several materials used in the intricate design of modern mobile phone batteries. Now we will discuss about zinc. Zinc is a chemical element. It has symbol Zn, atomic number 30, and its mass number is 65.38. It is the first element in group number 12b. It is a d block element present in period 4. Its electronic configuration is given. It is solid at standard temperature and pressure. Its density at room temperature is 7.14 grams per cubic centimeter. Its density when liquid at its melting point is 6.57 grams per cubic centimeter. It is an amphoteric oxide. Do you know what is meant by the term amphoteric? Amphoteric means the compound, atom, or molecule, any species which behave as an acid and base too. So zinc can behave as acid and base both. Its oxidation states are -2, 0, +1 and +2. Its melting point is 692.68 kelvins. Its boiling point is 1180 kelvins. Zinc is a slightly brittle metal at room temperature and has a shiny grayish appearance. Its crystal structure is hexagonal close packed. Uses of zinc. Zinc is used to galvanize other metals such as iron to prevent from rusting. Galvanized steel is used for car bodies, street lamps, safety barriers, and suspension bridges. Large quantities of zinc are used to produce die castings, which are important in the automobile, electrical, and hardware industries. Zinc uses range from metal products to rubber and medicines. It is used for making brass and bronze alloys. It helps in the extraction of gold and silver. Zinc oxide is widely used in the manufacture of very products such as paint, rubbers, cosmetics, pharmaceuticals, plastics, inks, soaps, batteries, and textiles. Zinc is an essential component of human body and required for proper functioning of body. Zinc in mobile phones. Zinc serves several purposes in mobile phones. Number one is galvanizing of components. Zinc is often used to coat steel and prevent corrosion through a process known as galvanizing. Some components in mobile phone, especially those in the internal structure and connectors, may have zinc coatings to enhance their durability and resist corrosion. Use of zinc in mobile phones. Number one is in battery production. Zinc is a component in certain type of batteries. For example, zinc carbon and zinc air batteries have applications in mobile devices, while lithium-ion batteries are more common in modern smartphones. Zinc-based batteries are still used in specific contexts. Die casting for phone casings. Zinc alloys are used in the die casting process for manufacturing phone casings. These alloys provide a balance of strength, durability, and the ability to be molded into intricate designs. These uses highlight the diverse applications of zinc in both the structural and functional aspects of mobile phones. A major use of zinc is in PCBs, which are printed circuit boards. Zinc is used in the production of PCBs, which are fundamental to the functioning of mobile phones. It is often used as a protective coating on PCBs to prevent oxidation and improve conductivity. Why zinc is used in mobile phones? Here are some reasons. Zinc is also alloyed with lead and tin to make solters using in joining electrical pieces together, such as pairs of copper wire. Zinc has also long been used in batteries due to its high power density and excellent electrochemical properties. Newer zinc batteries are also rechargeable as well as being recyclable. Zinc is used in mobile phones for various reasons, including its physical properties and chemical properties, such as corrosion resistance, battery technology, use in PCBs formation, etc. Batteries of mobile phone. As we all know that our mobile phones are portable, so their batteries should be of very good quality and they have to be charged. For this purpose, mobile phones use lithium-ion batteries. What are lithium-ion batteries? The majority of today's phones use lithium ion batteries. These batteries tend to use lithium cobalt oxide as the positive electrode in the battery, through other transition metals are sometimes used in place of cobalt, while the negative electrode is formed from carbon in the form of graphite. We will discuss about lithium and cobalt, and next we will see the working of lithium ion batteries. So, what is lithium? Lithium is a chemical element. It has symbol Li, atomic number 3, and its mass number is 6.9. Lithium is present in group 1 and period number 2 of the periodic table. Lithium is an S block element. Its electronic configuration is given. It is solid at room temperature. Its melting point is 453.65 kelvins. Its boiling point is 1603 kelvins. Its density at room temperature is 0.53 grams per cubic centimeter. Aluminium's density when liquid at its melting point is 0.512 grams per cubic centimeter. Its crystal structure is body centered cubic. It is a soft silvery white alkali metal. Lithium uses its compounds have several industrial applications, including heat resistant glasses and ceramics. Lithium greases, lubricants, flux additives for iron, steel, and aluminium production, lithium metal batteries and lithium ion batteries. These uses consume more than three quarters of lithium production. It is used in air purification system, typically in confined spaces to absorb carbon and maintain a breathable atmosphere with a strong affinity for carbon dioxide. Lithium hydroxide reacts with carbon dioxide to form lithium carbonate and water. Uses of lithium in mobile phones. The lithium ion batteries makes charging a device easier. There's no need to wait for it to discharge for 100% before recharging. Your device could remain plugged to electricity for a large period of time without side effects. Compared with traditional batteries technology, lithium ion batteries charge faster, last longer, and have a high power density for more battery life in a lighter package. When you know a little about how they work, they can work that much better for you. So this video will be helpful for you to understand the phenomena of your mobile phones and make them safe. Lithium is used in a variety of rechargeable batteries for electronics such as electric vehicles, digital cameras, mobile phones, and laptops. They also have a high power to weight ratio, high energy efficiency, good high temperature performance, long life, low self discharge. Most components of lithium ion batteries can be recycled, but the cost of material recovery remains a challenge for the industry. Uses in cameras and other portable electronic devices. Lithium batteries have become increasingly popular in the world of photography due to its high energy density, longer lifespan, and lightweight design. These batteries are commonly used in a wide range of cameras, including digital cameras, DSLRs, mirrorless cameras, and even some in film cameras. Hmm. Cobalt. Cobalt is a chemical element. It has symbol CO, atomic number 27, and its mass number is 58.9. It is a d block element present in group number 9 and period 4. Its electronic configuration is given. Its melting point is 1768 kelvins. Its boiling point is 3200 kelvins. Its density is 8.90 grams per cubic centimeter. Its density when liquid at its melting point is 7.75 grams per cubic centimeter. Appearance of cobalt. It is lustrous bluish gray metal. Its crystal structure is hexagonal close packed. Uses of cobalt. Cobalt is used in many alloy and superalloys to make parts in aircraft engines, gas turbines, high speed steel, corrosion resistant alloys, and cemented carbides. It is used in magnets and magnets recording media. It is also used as a catalyst for the petroleum and chemical industries. Cobalt is used as a drying agent for paints and inks. It is blue is majorly used by artists and in is used by craft workers in porcelain, stained glass pottery, enamel jewelry, and tiles. The radioactive isotope cobalt 60 is used in the treatment of cancer and to irradiate food. It is used in order to preserve the food and protect the consumer. Common uses of cobalt. The most common uses of cobalt are in some of everyday material we use such as magnets, ceramics, magnetic alloys, cobalt boards, glasswares, steel boating, radial tires, and it is also used in radiotherapy. Cobalt is widely used in batteries and in electroplating. Cobalt salts are used to impart blue and green colors in glass and ceramics. Uses of cobalt in mobile phones. The batteries in almost every smartphone, tablet, laptop, and electronic vehicle made today cannot recharge without the cobalt found in the dirt here provides maximum stability and energy density to rechargeable batteries, allowing them to hold more charge and operate safely for longer periods. Your phone has about 8 grams of cobalt in it. 8 grams means when you put it together, it's about the size of a mic. Why lithium and cobalt are used in batteries of mobile phones? Lithium is used in mobile phone batteries because it is lightweight and has a High electrochemical potential, allowing for efficient energy storage and release. Cobalt is often used in the cathode of lithium ion batteries to enhance their performance, stability, and energy density. However, there are ongoing efforts to reduce or eliminate cobalt due to ethical and environmental concerns associated with its mining and supply. Working of lithium ion batteries. Lithium ion batteries work through the movement of lithium ions between the positive electrode known as cathode and to the negative electrode known as anode. Number one is its discharging. During discharging, lithium ion moves from anode to the cathode through an electrolyte, creating an electric current. Number two is its charging. In the reverse process, during charging, the ions move back from cathode to anode. In this picture, during discharging, lithium ions move from working of lithium ion batteries. Lithium ion batteries work through the movement of lithium ions between positive electrode cathode to negative electrode anode. Discharging. Number one step is discharging. During discharging, lithium ions move from anode to the cathode through an electrolyte, creating an electric current. In this picture, you can see discharging process. In discharging, red colored lithium ions are moving from anode to the cathode. During charging, the ions move from cathode back to the anode. During discharging, blue colored lithium ions from green colored cathode move back towards the anode. What are anode and cathode in lithium ion batteries? The anode in lithium ion batteries is typically consists of graphite or cobalt, which allows lithium ions to intercalate into its structure. The cathode is often made up of lithium metal oxide. In this picture, orange colored is cobalt cathode made up of lithium metal oxide, and blue colored is anode made up of graphite or cobalt. Separator and electrolyte. Separating the electrodes is a permeable membrane that allows the passage of ions but prevents direct contact between the cathode and anode, avoiding a short circuit. The electrolyte usually used in lithium ion batteries is a lithium salt in solvent, which facilitates the movement of ions. When discharging, lithium ions leave the anode, moving through electrolyte towards the cathode. Electrons flow through the external circuit, creating an electric current. During discharging, the process reverses, with lithium ions moving from cathode to anode. What are touch screens? Touch screens in an electronic display screen that is also an input device. A user interacts with the computer, tablet, smartphone, or touch controlled appliances by using hand gestures and fingerprint movements to tap pictures, moving elements, or type words on the screen. These touch screens in mobile phones are interactive displays that allow users to input commands by touching the screen with their fingerprints or a stylus. There are different type of touch screens, but one common technology of touch screens is capacitive type touch screen. Following are types of touch screen. There are two main types of touch screens. Number one is capacitive type touch screen, and number two is resistive type touch screen. First, we will discuss about capacitive type touch screens. Capacitive touch screens are made up of layers of glass or plastic with a transparent conductive material like indium tin oxide coating the surface. Like I have told you earlier that rare earth elements such as indium and antimony are used in mobile phones. Here are their uses. This conductive layer stores electrical charges when you touch the screen with your finger, which carries a small electrical charge. It disrupts the screen's electrostatic field. This change is detected by sensors along the edges of the screen, and the device interrupts it as a touch input. In this picture, you can see capacitive touch screens work based on the principles of capacitance and the ability of the human body to store electrical charge. Here's a simplified explanation of how they work. Conductive surface. The surface of a capacitive touch screen is coated with a transparent conductive material, often indium tin oxide. Electrostatic field. An electrostatic field is created across the screen's surface by applying a voltage to the conductive layer. This layer holds uniform charge. Number three is touch interaction. When you touch the screen with your finger or a conductive stylus, it disrupts the electrostatic field at that point. This causes a change in the capacitance at the touch location and your touch screen works. Here you can see in this picture when you touch the finger of your when you touch your finger on your mobile phone, a distortion in the electrostatic field happens, and after this discharge distortion, charge flows through your finger to the mobile phone and your touch runs. Sensors detection. Sensors positioned around the edges of the screen detects the change in capacitance. The sensors are connected to a controller that processes the information. Number 5 is coordinate calculations. The controller calculates sent to the device processors. Device response. The device software interrupts the touch input and respond accordingly, executing the desired action such as opening an app or scrolling. Capacitive type touch screens offer advantages like multi-touch support, higher sensitivity, and durability. They are widely used in modern smartphones, tablets, and other touch enabled devices. Resistive touch screens. Another type is resistive touch screens consisting of multiple layers and a resistive coating on the top. When pressure is applied, the layers make contact at the specific point, creating a circuit. The location of the touch is determined by measuring the voltage drop along the x and y axis. Resistive type touch screen requires pressure because the layers should have to be in contact for the touch. Working of resistive touch screens. Resistive touch screens work on the principle of pressure and the change in electrical resistance of the point of touch. Here's a basic explanation of how resistive touch screens function. Number one is layered structure. Resistive touch screens consist of multiple layers, typically two flexible outer layers separated by a small gap. These layers are coated with a resistive material. Resistive coating. The outer layers have a resistive coating usually made of indium tin oxide. These coatings are conductive but have a high resistance. Non-conductive spacer. Between the two layers there is a non-conductive spacer that maintains a small separation. Voltage applied. The voltage is applied across the layers, creating a uniform electric field. In the absence of touch, the layers do not make contact. Here you can see that when pressure is applied, the layers come in contact in resistive type touch screens and your touch proceeds. Touch interaction. When you touch the screen with your finger or a stylus, pressure is applied. This pressure causes the two resistive layers to come into direct contact and the touch pointed. Circuit completion. The contact of the touch point completes a circuit leading to a measurable drop in electrical resistance at specific locations. Coordinate detection. The process of touch is determined by measuring the change in resistance along the x and y axis. The controller interrupts these changes to calculate a coordinate of the touch device response. The controller sends the touch coordinates to the device processor, which then translates the input into the appropriate action such as tapping on icon or entering text. What is difference between capacitive and resistive type touch screens? The main difference between capacitive and resistive type touch screens is in their working principle. Capacitive type touch screen work on the principle of capacitance and resistive type touch screens work on pressure. Differences between both screen types. Number one is difference between the technology. Capacitive type you relies on disruptions in an electrostatic field, and resistive type detects touch through changes in electrical resistance by power pressure. Touch sensitivity. Capacitive type have a highly sensitive supports multiple touch. Resistive type touch screens are less sensitive, may require more pressure, limited multi touch. Durability. Capacitive type touch screens are more durable because no wear prone layers. Resistive types are durable but flexible layers may wear over time. Accuracy. Capacitive type touchscreens are more accurate and precise. Resistive type touchscreens may be less accurate, especially with fine details. Visibility. Better visibility is shown in capacitive type because there are no effective additional layers. Resistive type touchscreens are slightly low in clarity due to layers. Stylus compatibility. Capacitive types works well with capacitive stylus. Resistive types are compatible with various stylus types including non-conductive applications. Capacitive types are common in smartphones, tablets, high touch sensitivity devices, and resistive types are used in industrial settings, POS systems where durability is crucial. Here a capacitive type touch screen and a resistive type touch screen both are shown. Do you know how does your mobile phones read your fingerprints? Because they have fingerprint sensors. Let's see what are fingerprint sensors. Fingerprint sensors in mobile phones are biometric security features that use the unique pattern of a person's fingerprint to authenticate their identity. Phones use one of three different technologies to read your fingerprint: optical, capacitive, or ultrasound. Optical fingerprint sensors. An optical fingerprint sensor reader is the oldest of the three. It uses a specialized miniature camera to take a picture of your finger, often backlit with the little LEDs or person screen. It had some limitations. These sensors are easy to fool, even a good photo can trick them, so it may be combined with the capacitive sensor. The second technology to check there is really fingerprint there. Capacitive fingerprint sensors. A capacitive fingerprint sensor uses a grid of tiny capacitors that store electricity, which is discharged only at the points where your fingerprint ridges touch. An array of thousands of capacitors can then be used to map the pattern of your fingerprint. Sometimes these sensors also support swipes or force sensing. Ultrasonic fingerprint sensors. The third and most advanced form of fingerprint sensors uses ultrasonics, much like the ultrasonic scanners used for medical purposes. An ultrasonic sound pulse is transmitted to your finger and the reflected pulse is measured. Bats, whales, and dolphins use ultrasonics to understand the shape of their surroundings. Likewise, the sensors on a smartphone use it to understand the 3D shape of your ridges in your fingerprint. It can even work through the phone screen. What are plastics? Plastic is a material which is consists of a wide range of synthetic or semi-synthetic organic compounds that are malleable and therefore they can be molded into solid objects. Plasticity is the general property of any material that involves permanent deformation and without breaking. Polymer's name is derived from elastic and plastic properties. Material engineers generally classify plastics by the chemical structure of the polymer's backbone and side chains. Some important groups in these classification are acrylics, polyesters, silicones, polyurethanes, halogenated plastics, PVCs, which are polyvinyl chloride, polyamide resins, and etc. Uses of plastics. Plastics has a wide range of uses in different materials like water bottles. Many things around us are made of plastics. For example, polythene, toys, bags, chairs, tables, boxes, etc. There are some well-known plastics around us. These are polypropylene in the form of chairs and tables and polystyrene in the form of plastic spoons and forks and cups. Polyamide, usually known as nylon, used in toothbrushes and car parts, etc. Plastic is used across almost every sector, including to produce packaging in building and construction, in textile consumer products, transportation, electrical and electronics, and industrial machinery. Why plastic is used in mobile phones? In mobile phones, plastic is commonly used for the phone's casing due to its lightweight, durable, and cost effective properties. It allows for design flexibility and is often used in combination with other material to achieve a balance of aesthetics and functionality. Plastic account for 50% of your mobile phone's weight. In addition, enclosure plastics are used in a wide range of cell phone applications. For example, Google used 21% recycled plastic in its latest Pixel 7e mobile phone. What is silicone? Do not confuse with the element silicon and this silicon. That was the semiconductor silicon, and it is a resin of plastics with spellings Silicone. Silicon is a synthetic material made from silicon, oxygen, carbon, and hydrogen. Applications of silicone are in aerospace, cookware, automotive, ophthalmology, mold making, personal care, dry cleaning, fire stops. An interest, a very interesting use of silicone is subdermal implant. A subdermal implant is a body modification placed under the skin, allowing the body to heal over the implant and creating a raised design. It's weird, but people do it. Such implants fall under the broad category of body modifications. Many subdermal implants are made out of silicone, either carved or molded injected. Many people who have subdermal implants use them in conjunction with other types of body modifications to create a desired dramatic effect. This process is also known as 3D implant or pocketing. Here is a picture showing people with subdermal implant. Why silicone is used in mobile phones? In mobile phones, silicone is often used in various components like protective cases, buttons, and seals. Its flexibility, resistance to heat, and durability make it valuable for creating protective and functional elements in mobile devices. Silicone is also used to seal vulnerable areas, helping enhance the phone's resistance to water and dust. Radiations emitted by mobile phone. Mobile phone emit radio frequency radiations, a form of electromagnetic radiations. This radiation is non-ionizing, meaning it lacks the energy to remove electrons from atoms or molecules. Mobile phones use radio frequency radiations to communicate wirelessly with cell towers. It's important to note that level of radio frequency waves emitted by mobile phones are regulated to ensure that they stay within safety limits. While extensive research have been conducted, the long-term health effects of exposure to low levels of radio frequency radiations from mobile phones are still a topic of ongoing scientific investigations. Advantages of mobile phones. Mobile phones has a wide range of uses nowadays. Number one is its use for communication. Mobile phones facilitate instant communication, allowing users to stay connected with family, friends, and colleagues regardless of their location. Accessibility. Mobile phones provide easy access to information, services, and the internet, enhancing convenience and efficiency in various. Advantages of mobile phones. Mobile phones has a wide range of uses nowadays and greatly impact our lives. Number one is for communication. Mobile phones facilitate instant communication, allowing users to stay connected with family, friends, and colleagues regardless of their location. Accessibility. Mobile phones provide easy access to information service and the internet, enhancing convenience and efficiency in various aspects of daily life. Emergency situations. Mobile phones play a crucial role in emergencies, enabling quick communication for assistance, reporting accidents, or seeking help. Multifunctionality. Modern mobile phones serve as versatile devices offering features like cameras, GPS navigation for location, calculators for calculation, alarms for time, and a wide range of applications for various tasks. Productivity. Mobile phones contribute to increased productivity by allowing users to work remotely, manage schedules, access emails, and collaborate on projects while on the go. Entertainment. Mobile phones offer entertainment options such as games, music, video, and social media, providing users with a convenient source of leisure and relaxation. Information sharing. Mobile phones facilitate the rapid sharing of information through text messages, calls, and social media, fostering communication and connectivity. Education. Mobile phones can be used as educational tools, providing access to online courses, educational apps, and a wealth of information for learning purposes. Navigation. Built-in GPS, global positioning system capabilities in mobile phones assist users in navigation unfamiliar locations, making traveling more accessible and efficient. Financial transactions. Mobile phones enable secure financial transactions, including mobile banking and digital payments, contributing to the ease of financial management. Mobile phones have made the world a global village. You can order your food by just one tap. You can shop anything online. You can ride your books for traveling. You can book your rides for traveling. Disadvantages of mobile phone. Number one is distraction. When you are using mobile phone, it distracts you from the whole world. Wastage of time and addiction. Addiction of anything is bad, and addiction of mobile phone is bad because you waste all of your time in using mobile phones and you lose interest in everything. Cyberbullying. Cyberbullying is harassing someone online. Sleeping disorders, loss of study, health problems, and ear and eye problems because mobile phones emit radio frequency waves. Impacts of mobile phones on environment. Mobile phones impact our environment greatly. Some are harmful or hazardous effects of mobile phones on environment are not only because plastic housing of the phone contribute to the dangerous problems of microplastic, but there's an even greater issue of electronic waste. Under 16% of all e-waste is recycled each year, meaning much of these precious materials end up in landfill. Not only does excessive smartphones use keep you mentally engaged late into the evening, the blue light from the screen can actually interfere with your ability to fall asleep and may increase your chances of insomnia. Too much typing may cause tendons in your thumbs to become inflamed and sore. The production of smartphones requires the extraction of precious metals, rare earth elements, and many other natural resources. Many of these resources are found in ecologically sensitive areas, leading to habitat destruction, deforestation, and soil erosion. Mobile phones are difficult to recycle. Researchers say that slimmer and more compact electronics are the harder it is to make them apart from recycling. Design trends are now believed to play a growing role in the problem of electronic waste management, since thinner tablets and phones with fewer components are harder to disassemble and are increasing the cost of recycling. Health issues due to mobile phones. Number one is central nervous disorders such as lack of sleep and a lot of other problems. At number two, we feel headache, fatigue, warming air, and lack of concentration. Our mobile phones also affect humans' heart rate and higher the blood pressure. In males, it also affects their sperm count, sperm motility, and sperm morphology. Linear economy. Linear economy is, let's see the role of mobile phones in linear economy. For it, we will discuss first what is linear economy. Linear economy is a traditional economic model where products are produced, used, and then discarded as waste. In this linear model, the end of the product's life often results in disposal in landfills, contributing to environmental concerns. The role of mobile phones in a linear economy is significant. Mobile phones have relatively short life cycles due to rapid technological advancements and consumer demands for new features. As a result, a large number of old or obsolete mobile phones are discarded, contributing to electronic waste concerns. Role of mobile phones in linear economy. In linear economy, the typical life cycle of a mobile phone involves extraction of raw materials, manufacturing, distribution, use, and ultimately disposal. This approach can lead to resource depletion, environmental pollution, and increased waste. To address these challenges, there is a growing emphasis on transitioning to a circular economy for electronics. Let's see a difference between linear economy and circular economy. In linear economy, materials are create waste after their use, and in circular economy, materials are collected and reused after every use. Role of mobile phones in circular economy. A circular economy aims to minimize waste and make the most resources by promoting strategies such as recycling, refurbishing, and extending the lifespan of products. In the context of mobile phones, efforts are being made to design more sustainable devices, promote recycling programs, and encourage responsible disposal practices to mitigate the environmental impacts associated with the production and disposal. Steps to lower the hazardous effects of mobile phones. Mobile phone companies are increasingly taking steps to transition towards a circular economy by implementing various strategies to reduce wastes, promote recycling, and extend product life cycles. Some common steps include: Apple has reduced the size of iPhone boxes and chargers production along the phones to lower their manufacturing and hence less fuel burns in the production, and it lowers the overall carbon footprint of the company. Some companies are using recycled materials and making modular designs, allowing users to easily replace specific parts of the mobile phones instead of changing the whole phone. Advanced and extended softwares are being used in phones to make them use for long terms. Here are some bookmarks for this presentation. In conclusion, I want to say that like everything has pros and cons, likewise mobile phones also have both positive and negative impacts on humans. Now it's up to us that how we use it. Addiction of anything is bad, so if we use it in an appropriate way and at a particular time, it will be a very beneficial and informative for us. And its overuse or negative use make it dangerous and hazardous for us. And that's it for today. I hope this video will be helpful for you to understand the chemistry of mobile phones. Thank you so much for your attention, and for any video of science and related knowledge, kindly subscribe the channel Dr. Hamad Majid.